Hi everyone, this is a update here of my testing coils for figuring out if there's an advantage for utilizing a coil in a different configuration. Right now that is a microwave primary coil that's in there, this guy right here, and that's pretty well as close as it can to my magnet rotor here, which is 1 inch by 1/8 of an inch Neo N42 magnets, and this little white spot here is for my optical RPM reader, which is all set up and allowing to read the RPM. And I've just added this piece here so I could just easy hot glue a coil on it and just screw it in. And then I have this mechanism here that I can crank, which brings in and out the coil for precision adjustment once I've got it positioned. So this box is being turned by a Ryobi bench grinder motor, which is it's rated 2.1 amps at 120 volts at 3,600 RPM. It's got a 1/2 inch arbor on there, and that's the way the motor is mounted. And on this side here is this is all Lexan. These are Lexan sheets here inside as well, and that's a Lexan rotor. Lexan does not crack, so it just can't break apart or anything when it's turning. And we're going to have this running at full RPM. And I've got a switch here to start it up. And this protective cover here, very nice solid latches here. No problem with any, there would be no accidents utilizing this. So let me start it up and I'll come back. Okay, it is running, as you could probably see right now. That's the inside of the box here with the rotor turning, and that's the outside of the box, and again another Lexan sheet here. And let's do a test here on the RPM. So we got 3,539 RPM, and that's pretty well full RPM. And here is my quality meter. This one here is displaying the amount of voltage that is going to feed that Ryobi motor. And because I have it set to my Variac, and I tune it down to be able to see the difference when we engage the coil. If I have like the full 120 volts going to it, you don't see much difference when I load the coil on. So right now I've got it tuned to 67 volts, pretty well exactly, that is feeding that motor. And I have this meter here, which is my next best meter, hooked up in measuring the amps. So right now that motor at 67 volts is drawing 0.56, so 565 milliamps, and that's about its most efficient at full RPM. If I start dropping the voltage anymore, it's going to consume more current, or if I start raising the voltage, it'll start again using more current. So that's the information there I have. And now what we'll do is we'll hook up a load. Okay, so here's where the coil is coming to from the box, the coil in the box, to this point here. I left this plug so I can have terminals to attach clips and all you want. I got my scope probe attached to across it here, and one leg going onto a 1 ohm resistor. That's a 10 watt 1 ohm resistor, and the other leg isn't connected yet. And parallel with that, I've got two 60 microfarad AC capacitors, well, 57.61 each, and that gives me a nice a little bit more power at the resistor here. So right now I'm going to load the resistor. Just show you once more here, we got 3,540, so nothing's changed. and I put my good quality meter across the resistor here to measure the correct frequency on AC, and I'll go ahead and load the coil. Oh, okay, the other thing I'll do too, this meter has this nice relative function, so I'll hit that and it gives us a 0 point here, and then we can see how much amps it's going to take when we load the motor. So the resistor is loaded and we're drawing 42 milliamps with that coil loaded, and that's a coil, it's in the standard way, nothing exciting there. And our RPM has dropped to 3,527 from our 540. And now the resistor is loaded, and we can see our voltage across that resistor right here. So we've got pretty well 1.5 volts, okay, or 1.49 if you wish. I know it'll go up a little bit as the resistor heats up, so I don't know, let's say about 1.5 volts is going to be our average there. I've seen it up as much as 1.52. So there again is our current draw, and our resistor is under load. This is the scope shot with the data with the resistor under load. This is what my scope sees at 1.63 volts RMS at 240 Hertz, and peak to peak is up there, and that's what the form looks like with the resistor loaded, and this is what the form looks like with the resistor unloaded. And again, here's the data. So now what I'm going to do is change the position of the coil so that we pick it up on the side and see the difference what we can get there. Okay, it's running now with the coil mounted sideways, as you can see. So it's hitting just one side of that coil on the side, and we're getting a reading of 3,537 RPM. Same voltage, and we're drawing again 572 milliamps, and I'll put it to get a relative reading here. So now the resistor is unloaded, and I'll go ahead and connect the resistor. Oh, wait a minute, that's the waveform here before connecting the resistor, and there is the data there. The frequency is higher because of the extra bumps on the waveform. Let me connect the resistor now. And now I go ahead and connect the resistor. Resistor is connected. Drawing maybe about 4 or 5 milliamps with the resistor, the load connected. And the RPM is, so we lost about 5 RPM less, and obviously we're not going to produce the same voltage on that 1 ohm resistor. That's what the waveform looks like. It's crunched down quite a bit, and here is the data on it. So we have 0.68 volts across that 1 ohm resistor, and that is correct because if you look at our reading here on my good quality meter, exactly as well what the scope is saying, 0.68, pretty well close to 0.69 volts across that 1 ohm resistor. So there is the difference of the coil being picked up from the side here. And if somebody could crunch that data together there and give us a reading, give us the calculations of what the power is and all that, that would be appreciated. I don't have all the time to do all that, and I'm not good in AC current, so please help out with the calculations. So I'll post this. Thanks for watching. Bye now.